Welcome to Understand the Math. In this problem, we're asked to use an augmented matrix to solve the matrix equation AX is equal to 0 and AX is equal to B. We're then asked to write the solutions in parametric vector form and then provide a geometric interpretation and comparison of the solutions. Okay, we got a lot to do. What I wrote down in purple is how we can go ahead and get started on solving this. What we're going to do is we're going to take matrix A and we're going to augment it on the right by 0 and B. The reason that we're going to do that is we're going to want to solve both of these equations at the same time so we don't have to do repeated row reduction. We're then going to take this augmented matrix and we're going to put it in reduced echelon form, and we're going to solve for our vector x, and we're going to write our solution as a vector. That's what it means when we have to write a solution in parametric vector form. To start, we're going to take our matrix A, and we're going to augment it on the right with 0, and then our and then our vector B. So we have a 1, 4, minus 1. I'm just writing down our matrix A. And on the right-hand side, we have our 0 and then our B. This method is really nice if you have a lot of vector B's like B1, B2. You can do them all at once. Okay, so we need to put this in reduced echelon form. So I'm going to start by circling our pivot, and then I'll highlight these two because those are the entries that are going to have to go to 0. I'm going to write down the reduction that we're going to do. We're going to take row 2, and we're going to replace it with row 2 minus 2 times row 1. And then we're going to take row 3, and we're going to replace it with row 3 plus row 1. Our first row is going to stay the same. So we have a 1, 4, minus 1. And on the right-hand side, we have a 0 and an 8. And then we're going to multiply our top row by minus 2, add it to our second row. So we get a 0, a 0, a 0, a 0. Ah, it's all 0. And you know what? I think our last row is going to look like that too. We're going to take row 1 and we're going to add it to row 3. And we're going to get all zeros. Now let's go ahead and let's circle our pivot because that's the variable that we're going to solve for. Now we're going to have two solutions. Let's first find the solution to a times x is equal to 0. So that means we're going to use our 0 for our right-hand side. So we have an x1 plus 4x2 minus x3 is equal to 0. We're solving for x1 because that's our pivot variable. So we have x1 is equal to minus 4x2 plus x3. Let's now write our solution x in vector form. So I always tell students, write down your x first and then plug in. See, your x is going to be x1, x2, x3. Now we're going to go ahead and we're going to plug in. We're going to plug in for x1, so minus 4x2 plus x3. And then x2 and x3 are free. So that means they're going to go in as themselves. This is often a mistake students make. Those guys just go in as themselves. Now we can go ahead and we can split this up into a vector that multiplies x2 and a vector that multiplies x3. So we'll pull out an x2 and we have the vector minus 4, 1, 0. And then we have our vector x3 and the vector 1, 0, 1. That is our solution to a times x is equal to 0. Now we were also asked to give a geometric interpretation of the solution. So notice that we have 2 vectors and 2 free variables. If we have 2 vectors, we'll always have 2 free variables. So the number of vectors is going to determine the object. When we have 2 vectors, we're going to have a plane. So we're going to have a plane, and then we got to tell where the plane's located. We have 3 entries to our vector. So that means our vector is going to be in R3. So our geometric description or interpretation is that it's going to be a plane in R3. Now let's go ahead and let's solve a times x is equal to b. Let's go back up here and take a peek. We're going to have the same thing. We're going to have x1 plus 4x2 minus x3. And now instead of a 0, we're going to have an 8 on the right-hand side. We'll solve for x1. So our x1 is minus 4x2 plus x3 plus 8. Our vector x is again x1, x2, x3. We're going to plug in for x1. So we have a minus 4x2 plus x3 plus 8. And then x2 and x3 go in as themselves, just like they did. Now we're going to go ahead and split this up. We're going to pull out an x2, and we have the vector minus 4, 1, 0, just like we did above. And then we'll pull out an x3, and we have a 1, 0, 1, just like above. Now here's what's going to be different. We're going to have an 8, and then think of x2 as adding 0 and x3 as adding 0. So our vector on the right is going to be an 8, 0, 0. Again, we have 2 free variables. So that means we have the linear combination of those 2 vectors plus a vector 8, 0, 0. So the geometric interpretation of this, it's going to be a plane in R3. But now here's where the difference comes. This plane is going to pass through our point 8, 0, 0. To contrast this to our solution to ax is equal to 0, for that solution, we said that it is a plane in R3. Now let's go ahead and add that it's through the origin. You can visualize it as adding the point 0, 0, 0. Now we can compare these two. These 2 planes are going to be parallel. So we can say that our solution to ax is equal to b is a plane in R3 through 8, 0, 0, and we can add that it is parallel to the solution a times x is equal to 0.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.